Hello everyone, welcome to the study of distribution systems practical of semester 4. First, let's identify the objectives of our practical. To determine the voltage distribution in a uniformly loaded distributor, in a uniformly loaded radial distributor, and in a uniformly loaded ring main distributor. Before moving to the practical, let's identify the theoretical background of this practical. A distribution system refers to the network of power lines and equipment that delivers electricity from high voltage transmission lines to end users such as homes, businesses, and other facilities. The distribution system typically operates at lower voltages than the transmission system. A distribution system includes a variety of components such as transformers, circuit breakers, switches, fuses, and other protective devices that are used to manage and control the flow of electricity through the network. The system is typically designed to provide reliable and efficient power delivery to customers while also maintaining safety and minimizing the risk of power outages and other disruptions. A uniformly loaded cable is a cable that is subjected to a uniform load per unit length along its entire span. When such a cable is in use, the load distribution along the cable can be calculated based on the cable's properties and the magnitude of the load. Understanding the load distribution along a uniformly loaded cable is important for ensuring the cable is designed and installed properly to safely handle the applied load. A uniformly loaded radial distributor is a power distribution system that consists of a set of feeders that emanate from a single source point and deliver power to multiple loads at different locations. When such a system is in use, the load distribution along the radial distributor can be calculated based on the characteristics of the feeders and the magnitude of the load. A uniformly loaded ring main distributor is subject to a uniform load along its entire length, with the load varying depending on the characteristics of the feeders and the location of the load. In a ring main distributor, the current flows in both directions along the loop, which can affect the voltage drop and losses along each feeder. Let's move to the procedure. Now let's have a look at the equipment used in our practical. In 5-module uniformly loaded distributor, there are series resistances and shunt resistances connected in each module. So, this is a scaled setup of an actual distribution system. According to the data given here, we can assume the lengths of each distributor. Scale factors used in table 2 can be used in your calculations. Part A. Uniformly loaded distributor, one end open circuit. Here we consider a uniformly loaded cable which is fed only from one side by keeping the other side open. We have chosen module 1 for this test and have connected the variac as shown in the figure. This distributor has 8 sections. First, adjust 90 volts and give that to the module and measure the voltage at each section using a digital voltmeter. This is the physical arrangement of uniformly loaded distributor, one in open circuit condition. Adjust the voltage at one end to 90 volts using variac and digital voltmeter. Measure the voltage at each section and note down the reading. Here are some sample observations for uniformly loaded distributor, one side open circuit condition. Part A. Uniformly loaded distributor, both ends 90 volts. Connect both ends of module 1 to the variac and feed 90 volts as shown in the figure. Measure the voltages at each section as previously. This is the physical arrangement of uniformly loaded distributor when both ends at 90 volts. Adjust the voltage at both ends to 90 volts using variac and digital voltmeter. Measure the voltage at each section and note down the reading. Here are some sample observations for uniformly loaded distributor, both ends 90 volts condition. Part B. Uniformly loaded radial distributor. Connect module 1, module 4 and module 5 and feed 90 volts to each module using a variac as shown in the figure. Measure the voltages at each section as previous. This is the physical arrangement of the uniformly loaded radial distributor. Connect the modules 1, 4 and 5 of the uniformly loaded distribution lines and adjust the voltage at one end to 90 volts using variac and digital voltmeter. Measure the voltage at each section and note down the reading. Here are some sample observations for uniformly loaded radial distributor. Part C. Uniformly loaded ring main distributor without tie line. Connect modules 1 to 5 as a ring main and feed 90 volts to a junction using the variac. Measure voltages at each section as previously. After measuring the voltages, we have to determine the minimum voltage and the point at which it occurs. This is the physical arrangement of the uniformly loaded ring main distributor without tie line. Connect all the modules and feed one junction with 90 volts. Measure the voltage at each section of ring main distributor and note down the reading. And determine the minimum voltage and the point at which it occurs. Here are some sample observations for uniformly loaded ring main distributor without tie line. Part C. Uniformly loaded ring main distributor with tie line. Connect modules 1 to 5 as a ring main and feed 90 volts to two junctions using the variac. Here, Select the junction used in previous part and one of the junctions adjacent to the minimum voltage points. Tie lines are indicated in green and orange colors. Measure the voltages at each section as previously. This is the physical arrangement of the ring main distributor with tie line. Connect all the models and feed one junction with 90 volts. And measure the voltage at each section and note down the reading. Here are some sample observations for uniformly loaded ring main distributor with tie line. Do the calculations using the readings obtained when the practical is carried out. For discussion, answer the following questions.